Hello, my name is Jared Tambe, and today we'll be discussing a coding problem that involves dynamic programming approach. I'm going to talk about the problem first, and then I'm going to talk about this file, which is solution, which contains solutions. This basic approach, which fails to generate the result using for loops. Then we use a memoization approach, which also fails for high load of data. For some load of data it works, and for extremely high load of data within the constraints it does not produce result. And lastly, we have the approach that actually works. I'll be discussing this and my helper classes and whatever things that I've built for this. And then lastly, I will also tell you another tool that you can use to actually find out whether what you've done is working in the test environment, which is using lead code. But we'll get to that later. So first go to the problem definition. A shopper wants to buy a pair of jeans, pair of shoes, a skirt, and a top with budget dollars, with given budget. The input given to the programmer is prices of jeans as an array, prices of shoes as an array, prices of skirts as an array, prices of tops as an array. So prices of tops can be 1, 2. And the total budget allotted for shopper is 10 in this case. They also have constraints on ABCD, where ABCD are the sizes of 4 price arrays. They are from 1 to 1,000, so these price lists can be of length 1,000. The value inside those, each price item can be 1 to 10 raised to 9, which is a billion. And the total budget is also 1 to 10 raised to 9, a billion. This must be a billionaire's problem. Okay, let's find out if they're given an example. For prices of jeans array as with only one item in it, 4. So there's only one jean, one price available for a pair of jeans, which is $4 in this store. Prices of shoes can be 3, 4, 1. Prices of skirts can be 3, 2. Tops is only a price 4. And then total allotted budget for shopper is 12. Within these constraints, if the shopper wants to buy all 4 products, jeans, shoes, skirt, and top, the shopper has 2 ways within which he or she can buy those items. A shopper can buy a pair of jeans for price 4, a pair of shoes for price 1, a skirt for 2, and a top for 4, which is one combination. The shopper can also buy pair of jeans for price 4, pair of shoes for price 1, a skirt for price 3, and a top for price 4. So there are 2 combinations within which fit into the budget within which shopper can buy all 4 items. So the answer is 2. Otherwise the answer is 0. They need to be able to buy all 4 items, and they need to fit in the budget. And these are the constraints. Right, let's come to solutions. I've used C# as my language, and this window is Visual Studio. These are the constraints. This is the problem definition in brief. The constraints arrays. These arrays are of length, maximum length 1,000, and the budget can be billion, and the price and the values inside these arrays can be up to billion. All right. I have a shopper class which has a list of pair of jeans. So these are the prices that I've done. This is the actual budget of the shopper. These are the prices that they're offering to the shopper for tops and skirts and shoes. I have a generate data function, which is a helper function in which I generate the pair of jeans, the prices for the jeans, and the total values, the array length, and the actual values of the prices. So I'm using a random function here to generate those values and array size. This is my actual budget. This random function takes in has a method called next, and that uses two inputs, two params, which can be start to end. So with this, I'm telling them, give me a random value from 50 million, this is 50 million, to a billion. Those are really pricey genes. And I have an array size of 900 to 1000 because our constraint is up to 1000. This 1000 is defined over here, and the billion is defined over here using math function. So I have the PairOfJeans list, I have PairOfShoes list, their prices and their prices, tops and the prices. This is the random number generated array size, and I use that array size to keep adding the values in there. Finally, I assign all these things to my shopper class as object, and then return that shopper. That's what happens here. And in the main function, I create a shopper object, and then I generate the data, and use that generated data to call my actual function. First, I'm going to show you a simple approach. I also run this for 100 times, so we know that the output we generate is actually, or the code that we write is actually generating output. It's not just by a fluke or something. Okay, so I generate the data and I call my function to generate how many options are available within these pairs of jeans prices and the pairs of shoes prices, tops prices, and my actual budget. And then I print out the value at the end. So obviously, the thing that we can do is for these pair of jeans prices, for these shoes prices, the skirt price, and then this top price, if this price fits in my budget, which is dollars, then I'm saying I have an option or a combination within which I can buy all 4 items. It's valid. This is only intuitive. However, this does not generate the output even once. This is really for a high number of values, of course. Or maybe even the midway, I don't know. I haven't tested that. But definitely it does not produce the output. Let's run that. This is a console app. I'm saying hello world, and then for the number of times I call this, give me my options generated. It says it's still on the attempt number 1. Quite a few, well, a few seconds, and it's still not generated any output. This is not acceptable. So this approach has definitely failed to produce the output for this much data. However, the approach that we've done is kind of intuitive. So we want to build on top of this. What you can see over here is for a pair of jeans of 0, of index 0, I calculate value of B of 0, C of 0, D of 0. And then for A of 1, again, I calculate B of 0, C of 0, D of 0. And then B of 0, C of 0, D of 1. And B of 0, C of 0, D of 2, 3, and until the end of D. Then I go C forward 1, 0, 2, 0, 3, 0, and likewise. These values are constantly calculated. What if I can have those values for A of 0, these values calculate, all these values calculate for A of 0, for A of 1, we can now reuse those values as opposed to calculating, as opposed to looping all this thing all over again. That is called dynamic programming, and the term is memoization, where you can actually calculate the values, store somewhere in the memory, and just use that memory to access the value, the next iteration, for the next iteration. Okay, we can go there. This thing also has something else over here, which I'll talk about later. Let's come to the memoization approach. So what we do is the last two loops, these values are memoized, but these values are captured somewhere else. I forgot to explain this. If we could do this for a of 0, these values can be calculated and kept somewhere else in the memory. This same idea can be applied here as well. For b of 0, all the values of c0, d0 are calculated. For b of 1, all the values of c0, d0 to d1 to d2, 3 are calculated and kept somewhere in the memory. So that is what is happening over here. For C and D, if the price of skirt and the price of top is less than my budget, then I'm adding them in a memory. This memory is a dictionary. Key is string, and the actual value is the price of them put together, summation of those two items. And what I've done here is all these arrays are sorted. Top, skirts, their prices are sorted from low to high. That means when this iteration runs, let's say for skirt 5, the value of top 3, skirt 5 and top 3 value is less than budget, then it adds up. However, if for skirt 5 and top 3, the value is greater than or equal to my budget, then I'm saying break. Because if the tops are sorted, then for skirt 5 and top 4, always the value is going to be bigger than top 3. That means it's always going to break. That means it's always going to be higher than the budget. That means I want to break the loop, this loop, not only go for skirts calculation further on. This is what is happening over here. And I'm checking if the budget is less than actual, the price calculated is less than actual budget, because I still want to have a pair of shoes and a pair of jeans. This is only calculating for skirt and top. Okay. Then I use that C and D, these values calculated and memoized for the loop for this for loop of B. What I do here is I generate the memoization BCD, another dictionary with string as key and then value as actual summation of all the 3 items, which is skirt, top, and then pair of shoe. So what happens here is for each pair in memoization, the earlier calculation, I run all of that for the pair of shoes, which are all the prices of pair of shoes, which are also sorted. That means if this value, price of skirt plus top, and pair of shoes value is less than dollars, then I add it in somewhere in the memory. However, if this pair of shoes price and this earlier price is greater than or equal to my budget, then I want to get out of that loop, because all the subsequent prices of pair of shoes are always going to be bigger, larger than actual the value of iteration right now. Likewise, calculate memoization of BCD, and this is the key we allocate there. This is the value we set allocate there. And then finally, we use that memoization BCD with the same logic. We find out for pair of jeans if that value, if the memoization value, which is price of skirt, top, and pair of shoe, and this is memoized value, and my current value of pair of jeans is less than or equal to my actual budget, then I have found one combination within my budget where I can buy all 4 products. The shopper can buy all 4 products. Now pair of jeans is also sorted, so if the value of pair of jeans and pair value, memoization value of skirt, top, and shoe is larger, and all the subsequent values are also going to exceed the budget. So I can get out of that loop, this loop, and then continue again with the next pair of memoization. Memorize the value. Now we can run this. I also want to explain what happens here. I'll come to the system. So as we can see, it is making an attempt. Attempt number 1 is going on. It loads some console log or console or write line. It is not able to produce the result. It's taking quite long. Sometimes it actually does produce it, sometimes it doesn't. I think we've waited enough. It hasn't given a value. I'm going to run that again and see if this function actually works. Right, so it did produce a result. The array was so small that it actually, the number of combinations turned out to be 0. And the next array again fails, does not give us the output. Alright, I'm going to stop here. What we see is the solution that we've come up with is not sufficient, and comment out. And this approach also fails. Before I move on to the next approach, I want to talk about this. I tried something over here to see if this approach actually works. This is something that I've added later on, which was in the code, but I've thought of this later after I did all this work. What I did here was when we sort our tops, skirts, pair of shoes, and jeans prices, what we can do is we can get rid of all the values that are higher than or equal to the budget for individual item. So if my top costs my actual budget or even higher, then I don't need to process those values. I don't need to have those values in my computations within the memoization. So I try to get rid of those. What I do here is I run a for loop for tops values, for tops prices, and if any of the prices higher, then I remove the entire range from there on to the end of that array, because all those prices are going to exceed since we have sorted all the values. So that's the logic we apply here. But even with this logic, but even after applying this entire logic of using a memoization of CD and then applying it to B and then applying it to the next loop actually failed. So what we needed to do was I had to apply this further division of data. See how we've divided this into CD and then applied to B? What I did was I applied it to, like we do in a tree, we have sort of a binary tree. We divide the data in 2 halves and then combine it together. We divide the data in 2 halves and combine it together as a parent. So next approach still uses the sorting and still uses getting rid of the data, which is actually going to exceed my actual budget. Still uses this. And then I have this memoization dictionary. What I do here is see how we calculate this data for CD. What I do is I calculate the data for A and B as well. Just for A and B. All the values are there. So we have memoization CD, like we had in the previous approach, and it uses skirts and tops if the price of skirt and top is less than the actual budget. Only then add it to memory because I want to have 2 more items, which is obviously going to increase the summation value. So I create this memoization, and the same logic I use for a pair of shoes and a pair of jeans and shoes. If the summation of these 2 items is less than actual budget, then add those in the memory, which is the dictionary. Then what we do is, then I run a for loop for 2 of those items, memoization of AB and memoization of CD. We're going to check if memoization AB is pair of jeans and shoes. It's outer pair. So within these 2 loops, we check if the pair of jeans and the pair of shoes value plus pair of skirt and pair of pair of shoes and jeans and skirt and top value is less than actual budget, then I say I found a combination in which I can buy all 4 items within the given budget. Now, these memoizations, they're also in increasing order because the way we create them here, these are in increasing order, so it's going to break. So it's always going to be less than the previous. The previous value is always going to be less than the next value over here. That's how it makes sure of that. And then we break if a single value is greater than my actual budget for inner pair, which is price of skirt, which is a pair of skirt and top value. Yes. Okay, so I'm going to run this, and then on 2. I'm also running this for 100 iterations. You can see that the number of options generated are really high, and the values are generated. Just loading, it's not stopping. Sometimes it takes a little while, but it is creating values. It is giving options count, number of options, number of ways in which a person can buy all 4 items within the given budget. For these high values of pair of jeans, shoes, tops, skirts, prices, and actual high budget. I am going to load this for about 100 times. Yep, 100 times. So we know that this is not a fluke and it's actually functioning and working. And once this is done, I will show you the lead code page where you can check for an error that says time exceeded and one where it actually shows output all the times. 82 pretty close. Okay, we see that this is 4 million. This is 16 million. I saw some 0 values too. Sometimes their options generated are just 0. I see quite high values. This is low. Yeah, this seems like a high value. 22 million options. 22 million ways in which you can choose 4 items to buy within the given budget. So that's good. This program works. It worked all the 100 times and produces output. Okay, let's go and see the other console, other page, where we can test this. That's the problem. Okay, this is the window where I have the code, which is the second approach we use, where there was memoization, but it only worked for low values, or low values of pairs of genes that are sizes of array. Let's see. Here, you use this CD calculation, and then BCD calculation, and then uses that BCD calculation over A. And as you can see, it has showed time limit exceeded. Exceeded. Try another time. Sometimes that code actually works. Look over here. It has shown the number of options. Time limit exceeded. Alright. So most of the time it fails though. Okay. We have the second approach that we use, which is the second approach of memoization we use, which is we calculate the values of C and D, memorize those values, and we calculate the values of array of B and A, memorize those values, and then iterate over them to generate our result. This code has always worked. Okay, number of options produced, clear console. Number of options produced. Number of options produced. This is 58 million options. Cool. That's a pretty big number. Or on the lead code, you can create your playground and have this code generate your values. This tells you whether your time limit exceeds or whether it is within the limit. And I tried to have this value generated for 100 times, though it did not run. So you can only do it once over here. I have this playground has the actual function call and the class and the generator, data generator, and the call, the main function. That's all there is to it. Thank you. I hope someone finds this informative. This code is also uploaded on my GitHub page, which is this one. JSON is my username, and here's the code file within. Go to profile, and then within the repositories, find some C#, and then C#, there's this problem, which was from Amazon. I'm also using a benchmark.net library here, but I haven't done much with it, so don't bother to just ignore that. This gives the information like brief of the problem, buying for products within the budget, constraints for the arrays and the budget and the prices. It has all the functions, not just the calculate this option function. Alright, hope that helps somebody. Thank you.